Hello. Hi, can people hear me? Chat in the chat window if you can hear me. Awesome. Excellent. Hi, guys. Hi, everyone. Let me get back off the screen share. Okay. Getting ready to start. It's by the way, it's really hot over here today in the UK. And to reduce the sound or to improve the sound quality, I've turned off my fan. So I'm going to start sweating profusely over the next 40 minutes. So I apologize for that. But hopefully we can, yeah. Whew. Hopefully if you keep the questions nice and light, I won't get too sweaty. But we'll see. Okay. Let's actually then, I think we've got enough people now on the course. I think we're ready to start. Let me share my screen. Oh, Google Hangouts. Here we go. Okay. Wait, which way around am I going? I'm going this way around. All right. So let's begin. So this is a crash course in ES6, which is the next version of JavaScript and TypeScript. Now, it's not a deep dive into both of those subjects. Both of those subjects are pretty, there's a lot involved in each of them. But this is just going to give you a crash course, and specifically enough so that if you were thinking of coding in Angular 2, this should be enough to get you started in Angular 2 and actually get you quite far in Angular 2 as well. But there's still, as I say, there's still quite a lot of information related to ES6 and TypeScript that I won't be covering in this webinar. So this webinar is here to promote my new course on Angular 2 from zero to hero. It's on Kickstarter right now. I'm past 50%. If you like what you see in this webinar and you want more, then you can just feel free to go to codecraft.tv/ng2-Kickstarter. And then if you like what you hear, you can go ahead and support the Kickstarter. I'm afraid all the early birds have gone, but there's still plenty of options on there to pledge on the Kickstarter. So TypeScript is an open source programming language that's developed and maintained by Microsoft. Okay, this isn't a language that's maintained by Joe Bloggs, who works very, very hard on his GitHub repo. No, this is Microsoft, so a very, very large company. So it's got a lot of support. The same way Angular 2 is supported by Google, it's got a lot of support and backing behind it. It's not going to disappear overnight. Any time you spend investing in these technologies is going to be time well spent. Okay, so it was initially released in 2012, and it's basically ES6 JavaScript plus types and a few other features which give it a bit more expressiveness. So just as a reminder, so ES5 is the currently most popular version of JavaScript. And by popular, I mean the one with the greatest support across the different platforms and the different browsers. If you write your code that adheres to ES5 level JavaScript, it's likely to work everywhere. ES6 is the next iteration of JavaScript, and it's got quite a few features about it, and not every platform supports every feature yet. Okay, so the Chrome browser might support a subset of ES6. The Firefox might support a different subset. It just doesn't have everything doesn't all use all the features of ES6 yet. And then on top of that, we've got TypeScript, which is again just ES6 plus a few other bells and whistles, which are pretty cool. And so browsers don't support TypeScript. Most browsers barely support ES6. So how do we write our code in TypeScript? So we use something called a transpiler, which converts from one language to another. So we can write our code in TypeScript and have a transpiler convert it to ES6 JavaScript. But since most browsers, and actually even depending on your version of Node, even Node doesn't support all the features of ES6 yet, we can transpile our code into ES5. And that means we'll just be able to write in TypeScript and yet run that code across the broadest set of platforms without any worry of a code not being supported. Okay, that's just a quick intro into TypeScript, but actually this course is this webinar is covering ES6 and TypeScript. So for part of this, I'm just going to write plain old JavaScript code. I'm not even going to write TypeScript because a lot of what I'm discussing and I'm describing to is just normal ES6 JavaScript. Let me make sure. Okay, so the first thing the way I'm going to be running the TypeScript and the JavaScript and the ES6 JavaScript is via Node. Okay, so bring up my console here. Hang on, let me put my console. So different versions of Node support different features of the ES6 specification, with the later versions of Node supporting even more features of ES6, and the older versions of Node supporting lesser features of ES6. So just to take a look, if you want to have a look at, there's a site called node.green, which if you look at the top, this is the Node version 6.4. And on the left-hand side are all the features of ES6. And you can see it's quite a lot going on. And you can see depending on the version of Node that you're using, it might not support all the features of ES6. And that's including this thing called a harmony flag. So if you don't run Node with a harmony flag, there's even fewer features are supported in the older versions of Node. So if you have a look, you can see actually like the version 6.4 looks like it's got some pretty good support. Okay, a few things it doesn't have, but generally it's got pretty good support. So that's the version of Node we want to be using, and that's the one I'd recommend you use if you're playing around with ES6 on the command line. So I use a tool called MVM to install Node and to install different versions of Node on my computer. I can pass out the link when I send out the email at the end of this webinar, but you can just type MVM install 6 and it will install version 6 on your computer. And then if you want to use the version 6 right now, you just do MVM use 6. Okay. Now I'm using Node version 6 in this folder here. So now you can check by doing Node -v, and you can see I'm using Node 6.4, which is the one we want to use. Okay. Other thing I'm going to say is that sometimes some ES6 features are only switched on when we are in a use strict mode. So my recommendation when trying out ES6 using Node, or just generally, is just to always have use strict mode on, and I'll show you that with the first example. Okay, let's start writing some code. In fact, let me check to see if anybody's got. Let me start. Okay. Okay, cool. If you've got any questions, guys, just post them in the questions. There's a Q&A room. You can post them in there, or you can post them in chat. I'll check back with the chat room and the QA room, like every little section I go through, just to make sure there's no problems. But I won't be able to check it all the time because I don't have enough screen space on my screen. All right. So let's just start writing some code. So I'm using a web an editor called it's PyCharm. It's the same as WebStorm. It's basically just an editor, really. I've got a terminal at the bottom, which for some reason it's not maxing out properly. Anyway, I've got a terminal at the bottom, and I've got some folders on the left-hand side with just a blank project that I'm creating. And I've got two folders. I've got ES6 folder and a TypeScript folder. So I'm just going to start writing some ES6 code. The first thing I'm going to teach is this thing called let. So I'm going to create a file called let.js. This. And in the terminal at the bottom, I'm just going to cd into my ES6 folder, and I'm going to type node let.js. And nothing's going to happen right now because there's nothing. I haven't written anything in this file. Okay, so A confusing point for developers coming from different languages into JavaScript is the way variable scope behaves in JavaScript. And so what do I mean by scope? I mean the life cycle of a variable. When is it born and when does it die? And what is its visibility in different parts of the code? So in Java and C++, there's this concept of block scope. So that means if you declare a variable inside a block, let me call it block actually. Okay. That means it's only visible within a block, and a block is determined by these little curly braces here. So that would mean that on line 4, when we print out A, if we had block level scope, then A would not be visible and this would return an error. But if I run node.let, hope you can see that, guys, you should see that it actually prints out block at the bottom. So in JavaScript, okay, by default in JavaScript, we don't have block level scope, okay? In fact, in ES5 JavaScript, we only have 2 types of scopes. We have something called a global scope and a function scope. On here in JavaScript is we're declaring a variable in global scope and we're just assigning to it in our block level scope. That's what goes on. There's no such thing as block level scope, at least in ES5 JavaScript. So that's why when we print console log A, we can print it out on the screen. Okay, but we have something called a function level scope. So if I wrote something like var A is equal to global at the top, and then I wrote function hello, and then I wrote var A is equal to function, and then I tried to print out A on line 5. Okay, if I run that, you can see that A on line 5 is actually equal to the global value there. Okay, that's because the scope of the variable A is only within a function. So with JavaScript, by default in ES5 of JavaScript, we have only kind of global scope and function level scope. So a variable is either going to be in the global space, or a variable is either only going to belong to the global object, or it's going to belong to a function, and there's no such thing as block level scope in ES5. What am I trying to write there? I'm not sure. Anyway. Okay, so kind of let me give another example here. So you might say, well, you know, that's close enough, Atom. We've got function and global. Why do we need block? Well, we've got this example here that I can show you. And then in here, var A is equal to block. Okay. So this is when people come from other languages get really confused in JavaScript, because the expectation is on line 7 that the life cycle of A, the A declared on line 5 only exists with between these 2 braces. So typically you'd expect A on line 7 to equal function. Okay, but if we run this, see, it actually prints out block. So on line 7, the variable A is printing out block, which is really confusing. Now, the reason for this, again, is that there's no block level scope. So all that we're doing here is we're redeclaring A. So we're declaring A on the function level scope, and all that we're doing within this for loop is we're just setting the value of A to something else. And then when we print it out here, we just get function printed out. Okay, so I've kind of gone through a couple of examples of how we don't have block level scope and how we try and just have function level scope. So why is this an issue? It's an issue because we want block level scope. There's many situations where it's very, very useful. And for ages, we haven't had this in JavaScript. So JavaScript developers have come up with a bunch of workarounds for this. Now, the main workaround we use is something called an immediately invoked function expression. So this takes the trick of the fact that functions have their own scope and kind of just use that to define our own scope for our own variables. So if we wanted to have something that looks and behaves like block level scope, we would type function. We'd create an anonymous function like this. So this is just an anonymous function. And then to call an anonymous function, we wrap it with another pair of brackets. And then just because, how do we call a function? Well, we call a function with opening and closing brackets. So this is just creating a function and then calling it straight away. And then if we put var a block is into there, now this variable is declared in its own scope, in a function scope here. And so when we print it out on line 9, now printing out function instead of block. Okay. So okay, that solves the problem of kind of restricting the scope of variables, and these IIFEs or IFEs, they're used all over the place in JavaScript. You'll see them everywhere. Okay. And this is why we use them. We use them to kind of isolate blocks of code and define restrict the scope of certain variables. But it's a pretty verbose way of solving the problem. So with ES6, we have another way of solving this problem, a much more concise way of solving this problem, and that's with the let keyword. So if I get rid of all of that, and instead of var, I type the word let, and that's it. Now, when I run this code, oh sugar, what have I done? Oh, sorry. Yep. In fact, actually, I think I know what's going on here. Oh, I'm using node 5 for some reason. So mvm use 6. Let me try that one more time. There we go. You see, that was just an example there. I was using node 5, and node 5 wasn't supporting the let keyword properly yet. So I just moved to node 6, which is supporting the let keyword properly. But anyway, going back to where I was. So now when I call node, when I print it out on line 9, the only A which it can see is the A that's declared on 5, which is called function. The A that's declared on line 7 is only visible because it's defined with let, is only visible between these two braces. So with the let keyword, we can now declare variables which have block level scope, which just means that if you use let, that variable will only exist or will only belong and will only be visible to its outermost curly braces. Yep, that's let. It's kind of a long-winded approach to get to know what it means, but it does solve like a complex problem in JavaScript, although it kind of looks like a simple solution. Okay. Now, a classic, just to give another example of this, a classic interview question that I give, especially to students, is this one. I'm just going to copy and paste the code from here. Okay. Let me just go through this line by line really quickly. So I declare an array called funcs. I've got a for loop. And in this for loop, I create a variable y, which I make equal to the index that we're looping over. And to our funcs array, I'm pushing a function. And all this function is doing is it's printing out the value of y. Okay. So this is a really common interview question that I love giving JavaScript candidates. And what I'm doing at the end is for each of the functions I've created in the funcs array, I'm just calling the func. I'm calling this function that I'm creating here. Yeah. So what do you actually expect to get printed out here? What do you actually expect to get printed out? Yeah. So if I now type node let.js, I get 9 printed out, well, 9 times. Is that what you expected to get printed out? Maybe, maybe not. Most students, it wouldn't be unheard of for you to think that the words 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 would get printed out. Kind of intuitively, that's what you might expect. The reason for this is, again, that the y is not block level. Okay, this y, all we're doing here is we're declaring, it's the equivalent of this. Okay, by the time we actually call this function, it's logging y, and all that y is the last value that I had as it went through the loop, which was 9. So how can we solve this? Again, we can solve this now with the let keyword. In the previous interview questions, I would expect students to try and solve it by using an iffy, by using an immediately invoked function expression. But now with ES6, we can just solve it by using the let keyword. So just by putting let there, and that's all I'm having now. The variable y only exists between these two curly braces. And so if I now run node let, you can see it's now printing out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just as we would expect it. And because this kind of construct is just really, really common, this kind of construct of looping through an array and needing the index and needing the value that we're looping through, because it's so common, there's actually a shortcut for all of this. So we can just type let I equals 0 in the expression at the top. We can get rid of it there and just print it out here. Okay. So even though, and let me just prove that that works. Okay, see, it's still working. So even though this I is declared outside of this block, because of kind of just this construct and just the fact that we always use it in a for loop in this way, it's equivalent to this I being declared in within the block scope there as well. Yeah, equivalent to, I don't know, something like that. That's a nice little shortcut that we can have when using for loops and the let keyword. Okay, so like, there we go, there's let. So it's a very important addition to the JavaScript language in ES6. It's not a replacement for var. As you can still see, we can still use the var keyword in ES6. And this var still behaves exactly the same in ES6 as it did in ES5, i.e. it'll just declare a variable in the global scope or in the block or in the function scope. But generally moving forward, unless you have a specific reason to use var, and I haven't really come across a specific reason to use var in my code so far. I just expect you to always use the keyword let in ES6 just from this point forward. There's just no reason to use var unless, well, I can't think of a reason to use var. But yeah, that's let. Checking back in with you guys. Sure it didn't change A. I'm sorry, Phil, I don't quite understand the question that you wrote. But it sounds like everything's okay. There's no disasters happening. So I'm going to move over to the next topic. So our next topic is going to be the const keyword in ES6. So let me just now create another file called const.js. We're just creating normal JavaScript files. I'm going to add ustrip to the top just in case. Okay. So just like let, with const, we have block level scope. Okay. But unlike let, with const, the variable must be immediately initialized with a value that can't be changed afterwards. So if I try to now node const.js, just it'll print out an error at the bottom. So it's saying missing initializer in const declaration. And in my IDE, it's also popping up an error as well. So what that means is really we have to actually, when we use const, we have to actually initialize it at the same time. We can't just declare a variable. Okay, and just the same as before, both let and const have block level scope. So, okay. So this const temp that's declared on line 7 isn't visible or shouldn't be visible on line 9. So if I now run node const, it should give an error, and it's saying temp is not defined. Because it's not, because it has block level scope, just like let has block level scope. Okay. Okay. So, but the important distinction between const and let is that variables created by let are mutable. Okay. So if this was declared with let me get rid of this. If this was declared with let, we can make foo equal 2. Later on, we can change the value of foo, sorry, and that's absolutely fine. Node doesn't complain about that. Okay. But if foo was const, then it makes it immutable. Okay, you can't assign a different value to foo later on. And if we try to run this via node, you can see it's going to give us an error. So we're assigning to a constant variable. We cannot do that. It's not allowed. Okay, so that's kind of seems pretty straightforward, but there's kind of one really big gotcha with const in JavaScript, and that means that it does not make the value itself immutable. Okay, const only means that the variable that this variable name can't point to something else later on. The thing it points to can be something that changes. Now, the number 1 and the number 2 can't change that well, but an object can. Okay, we can do things to objects later on. So if we did const foo is equal to just an empty object, and then did foo property is equal to 1, then console log foo prop. Okay, that is actually fine. We get 1 printed out. So const doesn't stop you from actually changing the properties of the value that you're pointing to. It just stops you from doing stuff like this. So what you can't do, you can't reassign foo to another object. That will give you an error. Okay, but if you do want to kind of use const with objects, there is a way of getting around it. There's kind of a workaround, and that's to use something called object.freeze. So we do object.freeze. So that's a function, it's a built-in function. Okay, if we did object.freeze with the object we wanted to freeze, it doesn't have to be empty string. It doesn't have to be an empty object. It can be an object containing whatever properties that you want. Then actually, let me take off usestrict for now, and then if I actually printed it out, we actually get undefined. So in non-usestrict mode, it actually just silently fails. It just doesn't set the property in, and you'll just get undefined. In usestrict mode, fingers crossed if I got that right, in usestrict mode, it should be a lot more noisy about the error itself. So now it's saying, oh, look, can't add property, prop object is not extensible. Okay, so that's just a way of using the constant with mutable values. Now, another thing to remember about this is actually this is only a shallow freezing. So if prop, if this contained something else, so there's another object, the A within here is still mutable. So you'd have to kind of write something or figure something out in a way to make the whole thing mutable or immutable, or use a library out there which provides you with immutable properties, immutable collections and objects and stuff. Okay, so that's const. Let me check back in with you, see how we're going. Good, still looking good. Now let's move on to the next section. So next section is on template strings. Now again, we're still just working on ES6. We haven't even started on TypeScript yet. Yeah, TypeScript is just a superset of ES6. So most of what you're learning here is just as applicable, will just be just as applicable to you 2 or 3 years down the line when everybody's writing ES6 JavaScript. It's not just TypeScript that I'm teaching here right now. Okay. So with ES5 and ES6, we can specify a string with either the single quote or double quote character. So I can do let single is equal to hello world. And use the single quote characters, or I can use the double quote characters. Do console log single. Now it's clear. Here, node string.js. So here we go. We're printing out hello world. Nothing crazy going on here. But if we wanted to make the string span multiple lines, it can quickly become a bit of a pain. Well, it won't be such a big pain in my IDE because my IDE does a nice little trick here. So if I just press enter in the middle of a string, it will concatenate them for me. Okay. Now if I print it out single again, now it says hello world, my name is Asim. Okay. But if we also wanted to, print this out with new lines as well, we'd have to explicitly add the new line character into our code. And now, if I print node string.js out again, there you go. Hello world, my name is Asim. So now we're printing out on multiple lines. So although it's doable, it's quite messy. I always hated seeing code like this. It's just really hard for your mind to follow. But in ES6, we have another way of defining strings using the backtick operator. So what we can do is instead of the single quote or double quote, use backtick. You'll find it on your keyboard somewhere. So it's a slanted, so like a single quote slanted at 45 degrees. And then you can just type multi-line strings. Well, world, my name is Asim. Okay, now if we print that out, it's printing out exactly the same as before. So you can see it's actually also adding in the new line characters for us. We don't have to add them in explicitly. Okay, so that's one feature of these kind of template strings, these backtick strings. Another feature is variable substitution. So we can have another variable at the top. So let name equal Asim. Keep it like that. And within our backtick expression, I can actually just type name. And this will get expanded out to include the value of my name variable above. Okay, so you see it's $, curly braces, closing curly braces, and then there we go. So hello world, my name is Asim. So a really cool feature coming up in ES6 JavaScript, which is this backticks expression, and it's also called template strings as well. And they allow you to have multi-line strings, and they also allow you to do variable substitution. Let me check in with you guys again. Looking good. Okay, now let's move on to the next topic. The next topic is the fat arrow function. Starting to get a bit more interesting. So let me create another file in the ES6 folder called arrow.js. And again, this is just ES6. Yeah, it's not. We haven't touched on TypeScript yet. It's just standard ES6. Okay. So JavaScript has this concept of first-class functions. So this means in JavaScript, functions can themselves be passed around like any other value, even as arguments to other functions. So for instance, we have a function in JavaScript called setTimeout. And the first parameter for setTimeout is a function. And the second parameter is the number of milliseconds, after which it will call the function passed in the first parameter. So what I'm going to do is I'm just going to do console log setTimeout called. Okay, so let me clear that. Node arrow.js. If I run that, after 1 second, we now get setTimeout called. Oh, I've spelled that incorrectly. There you go, setTimeout called. Okay, so I'm sure you've either seen or used this kind of syntax many, many, many times in JavaScript. And specifically, this type of function here this is called an anonymous function because, well, it's not got a name associated with it. Okay. But with ES6, we have a slightly different syntax. If we wanted to, we have a slightly different syntax we can use to define anonymous functions, and that's called the fat arrow syntax. So all we have to do is delete function, keep the parentheses, and then it's equal sign and the less than sign. So it's the fat arrow function there. Okay, and if the function only ever contains one expression, one line, then we can actually short circuit this just one more level. We can actually just skip out, leave out these curly braces on either side, so we can be even more succinct in our code. So now if I run that again, 1 second, again, we just get a set timeout called printed on the screen. So that's that at a superficial level is the fat arrow function, okay? But what if you wanted to pass a parameter to this function? So what we can do is this. Let me just pretend there's a function called add. So I'm going to call function A, B, and that returns A plus B. Then we just add 1, 2, okay? All this does is it just basically should print out the number 3. There we go. As expected, it prints out the number 3. So with the now fat arrow function syntax, we can now express this more succinctly by just using a fat arrow. And since it's only got one expression in it, we can get rid of the curly braces. And actually a default feature of the fat arrow syntax is the last statement within there is automatically returned anyway, so we don't need to put the return statement in. So we just need to have that. So an even more succinct way of writing the same function. So now if we call node arrow.js again, it's just going to print out 3. Okay. So far you might just think that the fat arrow function, the fat arrow syntax is just kind of sugar, really, just a quicker way of writing anonymous functions with just a slightly fewer characters. And actually, that's not the case. Well, it's true that at times it can be a little bit more succinct, but it has one incredibly powerful feature. In fact, I'd say it's the main feature of the fat arrow function, and that is that it stabilizes the value of this. Now, those of you who've taken my advanced JavaScript course know that I go into a lot of depth as to this keyword in JavaScript and its instability in different situations. I'm going to show you a situation now where the value of this is going to be unstable. So, so let's imagine we have an object, okay, a bit literal. And I've got a property of name, call it asim. It's got a function called say later. Say later. What am I doing? Oh, say later. And that's a function. And all that this is going to do is it's going to console log. And I'll use backticks actually just for fun. This name. Okay. And then I'm just going to call object say later. Okay, so what do I expect to happen here? Let me clear and run. There you go. It just prints out the string asim. Can I zoom in on that? No. Okay. So why does this print out asim? Now, it prints out asim because this keyword in the say later function, this keyword points to the object. Specifically, this keyword in any function points to the call e, the thing that's calling the function say later. So the thing that's calling the function say later is the object, and that's why the this keyword inside the say later function points to object. Okay. Now, let's imagine we log the message using set timeout instead. So I do set timeout, and I add a function, again, just like before, 1000, and I just log it in here. Let's see what happens now. 1 second, we get undefined printed out. Okay. So the reason for this is that the value of this in a function, okay, depends on how that function is called. So the value of this in the say later function is object, because it was called using object. What is the value of this in this function? Like, what called it? You know, what called this function? And therefore, what is the value of this? Now, it depends actually on the platform that you're using. In a browser, if we're using just normally, this would point to the window objects. If it hasn't got a caller, it will point by default to the window object. If we're using use strict mode in a browser, it would then just be, this would then point to undefined, in which case there should be an error. In Node, in this scenario, this points to an object called a timeout object, which is just part of the set timeout implementation. Okay, but specifically, most importantly, this keyword here, in the context of this function, doesn't point to object. So this .name, it doesn't get the name property of the object. Okay, so this is one of the things that makes JavaScript code is kind of hard to understand and kind of hard to figure out, because this keyword, we can rarely trust it. You know, it's gonna be, we can't trust it's gonna be the thing that we expect it to be at all times, because it depends on how a function gets called. Okay, so this is a really common problem that we have. One workaround for this that you'll see all over the place, and there's other workarounds as well. My advanced JavaScript course covers a number of those, but I'd say the most common one is we kind of stabilize it ourselves. So we would type var self is equal to this. Sorry, not here. Top of our say later function. Well, at this point we know what this is going to be, or we hope we know what this is going to be, and we store it in self. So then later on in the set timeout function, we don't rely on this anymore. We rely on self, or whatever else we've called it. So we know the self is always going to point to object. So we hope the self is always going to point to object, because in some circumstances it won't. So if we run this, it will then get printed out as in. So that's a workaround that we use in ES5 JavaScript. And as you can imagine, with ES6 and the fat arrow function, this attempts to solve this problem for us using another mechanism. So again, just like before, if we turn this into the fat arrow function, definition of a function, go over that. Okay. Instead of self, we did this. Okay. And we ran. This is now printing out what we expect. So now in the set timeout function, this is set to object. It's basically set to the same thing that it is outside. And that's the key feature. That's the most important feature of the fat arrow function in ES6, is that if you use the fat arrow syntax, it will use, for this, it will use whatever the this is outside where that function is defined itself. So whatever the this is in this outer context where set timeout is defined, it will use that as the this for its own inner function. Okay? And that's it. That is basically, I believe, that the main use case and the main advantage of the fat arrow function is that it's another way of stabilizing or being very, very clear regarding what you want this keyword to point to. And what you'll see in ES6 code, if you start looking at it, is that people basically are using the this keyword a lot more, because we can trust now, if we're using the fat arrow function, it's a lot clearer, and we can trust that this is going to point to what we expect it's going to point to. Yeah, and that's it. That's the fat arrow function. Let me check back in with you guys. Still looking good. Excellent. Now let's move on to the next topic, which is destructuring. Okay, bring it up again. Destructuring. Now again, this is a feature of ES6. I haven't even started the TypeScript section yet. I'm just really covering the things that you need to know, that I think you need to know in order to understand, in order to have enough ES6 and TypeScript to be able to develop Angular 2 code. Okay, so there's still a lot more to ES6 and TypeScript than what I'm showing you. Okay, but anyway, this is destructuring. So what is destructuring? So destructuring is a way of extracting values from data stored in objects and arrays. So it's used in places like the left-hand side of an assignment, and how we extract the values is specified via something called a pattern. So let me first go through an example of destructuring objects. You create an object base. Let me just copy and paste it in so I don't waste so much time. Okay, so we've got an object. First name Asim, last name Hussein, age 39. And then what I can do is I can actually type const first F last L is equal to object. Okay, this is stuff you'd never have seen before. This is completely new syntax in ES6. And actually, underneath it, let me type console.log F, console.log L. Okay. So you might be guessing, you might be able to guess actually what this is doing. So what this is doing is from this object, which contains 3 properties, extract the property that the first points to and store that in a variable F, extract the property that last points to and store that in a variable L, constant L. So now, clear this. No destructuring. There you go. So now you can see it's printing out Asim and Hussein. Okay, pretty quick. So, but instead of extracting out into those things into new variables called F and L, what if we just wanted to extract it into a variable called first and a variable called last? Like, what if we wanted to extract it out into variables that matched exactly the same variables as were exactly the same properties as were in the object? Let me just show you first it's working. Okay, you can see it works just like before. It's just extracting out the property first from the object, storing it in a variable first, the property last, storing it in the variable last. But this is just a really common use case that we use with this destructuring. So it has a shortcut. If all we want to do is extract certain properties from an object and store those properties as variables, we can just skip out the stuff past the colon. Okay, so we can just do const first colon last is equal to object, and that's just a shortcut for what we had before. Okay. And finally, just not to show if this is important to know, but I'll just mention it anyway. We can actually also an object. You don't have to point to an object. You can just point to the result of a function as well. So if you can imagine having a function which returns just a whole bunch of values in an object, and then you just want to extract a couple of those values and use them in your code. It's a pretty neat feature and something I imagine we're going to start using a lot in ES6 JavaScript as we go along. Just return kind of multiple values from a function and then just extract what we want into variables in our code and move forward. Okay, so as well as object destructuring, we also have array destructuring, which works in a similar way. So imagine if I have a const array, which is an array with the values a and b. I can then declare const x and y. It's array. And this isn't, I'm not creating a new array here. I'm creating a variable called x and a variable called y. The x points to A, and the y points to a variable b. Okay, so A and B. So just the ways of extracting, of destructuring kind of arrays into individual variables which we can use in our code. Okay, so where can we use destructuring? So I've showed you how to use it here with variable declarations. So we can do things like what I've described above. So const x is equal to A. Okay, I'm not declaring an array of x. I'm declaring a variable x, which is of value A. Yeah, I'm declaring that. That's one way we can do it. We can just do it directly via assignment. So not const is probably a bad idea here. So I can have a let x. And if I just wanted to extract the first index, the first value of an array, I could just do square brackets x is equal to A, and then print it out like that. Print out. And a really interesting place that you can use destructuring is in the parameters to functions. Okay, the function func, pass in x, and then console log x, and it's called func, but with an array of A. Now, what's going to happen here is it's not going to print out the array A using destructuring because we've defined it in the function parameter list. It's going to extract out the first parameter, the first index of the array you pass in, and it's going to store that in the variable x, and I'm going to print out x. So now if I run that, it's just going to print out A as we expect. Okay, so it's not printing out. If I hadn't done this as destructuring, if I just pass this as x, what gets printed out is an array containing the one value, which is A. But we're using destructuring, which lets us extract out values from arrays into variables. Do that instead. Okay, so just digging into this a little bit more, this is actually really, really useful, especially in the case where we want to pass multiple parameters to a function, and maybe with some parameters that are optional. So we would typically write something like this. We would expect options to be an object that gets passed in, and then we might type options.x, and maybe something like or 0 or something along this line. Maybe or 1, that's a bad example. And then we would pass the function, we wanted to x with 3. Yeah, and then x3 gets passed in. That gets passed as options because it exists. It then will use the value of 3. If we passed in nothing, empty array, it would then use 1, which is the value there, and unlog that instead. Okay, but with destructuring, we can actually do this a little bit differently. We can just, again, just do x and do something like this. Now, if I pass x as 3 again, okay, this, it prints out 3. So when the function gets called, it will extract the property x from the object that gets passed in. And remember, you can pass in other values as well. It doesn't care. It'll just ignore those. It will ignore the y. All we care about is the x. So it'll extract the x, and then it'll print out the x or 1. Okay, but there's an even shorter syntax to this as well. So we can actually even provide default values, but provide them directly within the destructuring syntax. So we can just type x is equal to 1. And then there's no need to have a guard here to check or 1. If we pass in 3, it will use 3 for x. If we don't pass in any value for x, it will use 1. So again, this is something I expect to see being used more and more in ES6 JavaScript. A really, really useful feature of destructuring. But if you look through some of the Angular 2 code that I did in the quick start, or you're going to see in the later lectures, you'll see this is used all the time, this destructuring syntax. It's very, very useful. Okay, so that's it for destructuring. Let's check in with you guys again. Okay, everything looks good. There's a question. Right bottom corner of the code editor. Oh, I think that's just the time. I actually can't see it, to be honest with you. Okay, so there's a question. I'll answer it later on. Okay, so how are we doing for time? Oh, God, not great. Oops. All right, so that's all the ES6 stuff. Now let's actually start talking about TypeScript. So we can install TypeScript via npm. Okay, so npm is a node package manager. You do npm install -g because I want to install it globally, and you just type TypeScript. That's it, and it will install it. Now we want TypeScript at least 1.8 for our code. So to make sure you've got the right version, you type tsc-v, and there we go, version 1.8. Okay, so now I'm just going to go back into my editor, and I'm going to create a file. I'm going to call it hello.ts. Okay, use that, and I'm going to cd TypeScript. Make sure I've got the right version running. Yep. And in this file, I'm just going to type console log hello world. Hello world again. And then what I can do, you compile TypeScript. Remember, we can't really run TypeScript. We can only compile TypeScript into got some geese outside my window. So the only thing, we can't run TypeScript natively. You have to compile it into something. You have to compile it into either ES5 or ES6 JavaScript, or perhaps even something else, I suppose. So how you do that is you use the compiler, which is what we installed, that command tsc. So we can just type tsc, and then the name of the file. So the name of the file I created was hello.ts. Now, if you look in the folder here, you'll see it would have created a hello.js file. And let me just open that up. And actually, let me open it up in a vertical tab. So you can see here, there's no difference. It's actually, this code is the same whether you're in TypeScript. Oh, this code is the same whether you're in TypeScript or whether you're in JavaScript. So the TypeScript is in the left-hand side pane. The JavaScript is in the right-hand side pane. Okay. And then what we to do to actually run this file, I can just type node hello.js, print out hello world. Another thing that we can do with a tsc compiler, you can tsc-w hello.ts, and this will continue to watch for any changes that I make to this file and then compile them automatically. In my browser, in my editor, sorry, I have to synchronize to get it to load up that newly generated file on the right hand side. But as I type into my TypeScript file, it will automatically compile. Any errors would print out at the bottom here. Okay, so another thing that I can do is, if you look, hopefully, let me bring up via here. So if I do tsc-h, you can see there's lots and lots of properties that you can define here. One property that we'll be using in the course is parameter, sorry, is tsc minus, oh God, I've forgotten. Oh yeah, minus t, and then we can provide the target. Okay, so target we can say is either going to be ES5 JavaScript, which is the default, or you can say actually generate ES6 level JavaScript. Okay, you can provide just a bunch of those parameters on the command line, but that can be quite time consuming. So one thing that we might want to do is we might want to create a configuration file which we can use consistently with TypeScript. So we would type tsc -- init. And that has now created a tsconfig file, which I'll just open up using my editor. And you can see it's just got a bunch of common options that's going to be used in a bunch of places. And the key thing here is it's saying the target is ES5. Okay, so this tsconfig file.json, this will only work if you just do tsc-w. If you did tsd-w, it will compile all the TS files in the current folder, and it will also use the tsconfig.json file. Okay, if we'll do it as we're going to do in the rest of this course, we're actually going to name the files explicitly on the command line, just to make sure that any errors that we see are just for the file that we're working on. If we do that, then it's not going to use the tsconfig.json file. It's just going to use whatever parameters you pass on the command line. Just something to bear in mind. Okay, we've got basically 4 more sections to go on classes, decorators, modules, and types. So hopefully people are still okay and hanging around. Okay, fantastic. I'm probably going to be another, I'm sorry, people, I'm probably going to be another 20 minutes, I reckon. I apologize for running over time. Okay. Okay, let's go. I'm messing around, Asim. So now I'm going to create a file called class.ts. Okay, so JavaScript developers are often confused when working with object orientation in JavaScript for the first time. Since especially compared to other languages like C++ and Java, we would expect a keyword called class. Okay, like everybody else has got this keyword called class. We don't, right? So unfair. And would expect similar constructs that they'd have in C++ and Java. But JavaScript is, it is an object-oriented language, but however, it adheres to something called a prototype-based object-oriented programming model, where we can instantiate objects using other objects or some things called constructor functions. And to implement inheritance, we manipulate what's called a prototype chain. So in JavaScript, rather than using these things called class definitions as blueprints when creating instances, in a prototype-based programming language, we use other instances as blueprints to create new instances. We create instances from instances, not instances from classes. So we normally call the way OO is implemented in C++ or Java as the classical OO pattern, and the way it's implemented in JavaScript as the prototype pattern. And although the prototype pattern is a valid way to implement the object-oriented paradigm, the semantics is confusing for newer JavaScript developers. So in ES6, we have an alternative syntax to exploit the object-oriented paradigm. And finally, we have the class keyword that we can use. Now, quick note here that under the hood, even though we've got this new keyword called class, we haven't changed to using the classical OO pattern. Under the hood, it's still using exactly the same semantics as it used to implement object orientation in the past. Specifically, it's using constructor functions and the prototype chain. But it's just a much more convenient and less boilerplate syntax to create classes. Okay, enough talking, Asim. Let's create some code. So let's create a class called person. So we just type class person. And then to give it some properties, we can just type them in. So first name, last name. Okay, that's it. We've created our first class. Now, when we create an instance of this class, we call a function called a constructor. And to this function, we can pass in some initialization parameters. So I'm going to pass in first name and last name. Okay, and I can type this.first name is equal to first name, and this.last name is equal to last name. Okay. So now we can actually create an instance of a person. So I can call let asim is equal to, and I call new person. I can pass in a first name and I can pass in a last name. That's how I can create an instance using this new class syntax. For those of you who've used some of the older OO syntax in ES5 JavaScript, you'll see this is a lot more succinct and clearer. Okay, so you can also define functions on a class. I'm going to define a function called name, and I'm going to say return. I'll to use backticks. So this first name and this last name. Okay. And in fact, I'll add another function called who are you? Oop. And here I'll return, I'll use backticks again. So hi, I'm, and then, this variable substitution, we can actually even call functions. I can call the function name another result of that printed out in the who are you function. And then here I can console log asim.who are you. Okay. So now I can actually just go in here and I'm just going to compile my class to TypeScript. Okay. And now if I load this up in the right-hand side, you'll see some code that if you're used to ES5 JavaScript, you'll recognize as kind of how we'd write some OO functionality by directly adding functions on the prototype. But if we wanted to, we can actually just kind of target ES6. And this will transpile this into ES6. So there you go, it's transpiled it into ES6. Now, looking at the ES6, oh, where are we? So looking at the ES6 version versus the TypeScript version here, you can see it's very, very similar. That's because what we've written here so far is just as valid in ES6 as it is in TypeScript. Classes are not just a TypeScript feature, they're an ES6 feature. I'll be showing you some features that TypeScript add onto classes, but the base features here, what you're seeing right now, this is just as valid in ES6 as it is in TypeScript. Okay, so let's now add some inheritance. So on top of just encapsulating kind of functions and data inside of these kind of convenient little units of code and objects, one of the main advantages of object orientation is something called inheritance, which means we can create new classes which kind of have all the data and functionality of base classes. So I can define a class called student, which extends person, okay? And I can add another property called course. I can add a constructor because I'll need to be able to instantiate this instance somehow. So I'm going to, again, give it first name, then also last name. I'm also going to let it pass in a course as well. Let me kill out the right-hand side console for now. Screen for now. Okay. So how do I actually set the first name and last name? Okay, I'm extending persons. I don't have first name and last name available to me in my properties. How do I actually do this? Now, we have a special function called super. And what super does is it calls the constructor of the base class. So as it's creating the student instance, it then goes, okay, now call the constructor of the person, this function here, and pass in the first name and last name that I get passed in to my student class. And then you can just do this.course is equal to course. Okay, pretty simple. And what we can also do is we can override base class functions. So we've got a base class function called who are you. We can actually create our own, which overrides it with our own functionality. So now I want to return something a bit different. I want to return something, and I'm studying. Oh, I'm studying course. Okay. I want to actually return I'm this.name. I want to return this. You can do that again. So if you, how do I actually call a function on person from within a function on student? How do I do that? Well, I can do this. I can do super.who are you. Okay, pretty cool feature. So I'm now calling the who are you function on the kind of person layer of my student class. So now, instead of creating a new instance of person, I can create a new instance of student. And let's give it course TypeScript. Oh, now if I actually node cd TypeScript node class.js. Oops, what am I missing? I'm using the wrong version node. So nvm use 6. Let me try it one more time. There we go. Now I'm saying, hi, I'm studying Asmussen. I'm Asmussen, and I'm studying TypeScript. Because that's what this is printing out now, because it's calling the who are you function on the student class. Okay. Okay, so everything I've shown you so far, on this screen, this is pure ES6. What I'm about to show you now, this is now we're entering the realms of TypeScript. So the extra features that TypeScript offers on classes is something called an access modifier. So we can kind of extend this property of the base class. We can add a little string in front of it called private. Okay, this is TypeScript. This isn't ES6. This is TypeScript. Okay. And what private means, and let me show you actually. So now, if I try to write first name, so you can see even from my ID, it's telling me that the first name is not accessible. If I now look at my TypeScript compilation, you see seeing an error saying property first name is private and is only accessible within the class person. So this is what we call an access modifier, and it reduces the visibility of member variables, or restricts the visibility of member variables and member functions according to certain rules that you want. So private means that this member variable is now only visible to other functions within the class person. It's not visible from outside of that class person, and it's also not even visible from classes that extend from person. Okay, we could also make functions private. Now it's giving us two errors. It's saying who are you is private and only accessible from within class person, because we're trying to call who are you from the person who are you from our student who are you function, and TypeScript isn't allowing that as well. So there's kind of three access modifiers that are available. There's public, with private. There's protected, and protected means it can be called from it can be called from the class itself and any class that extends from that class. So if first name is protected, it's then allowed to be used from student. So if I'm now made who are you protected in the base class, you can see it's now allowing it to be called from the student class. If I did who are you, this should function fine. Okay, so we've got public, we've got private, we've got protected. Private. And we've also got public. So public is the default. Public just means anybody can have visibility to it. Okay, whether it's this class or whether it's any class that extends from this class, or whether it's any code that's external to these classes, they can all have access to it because it's public. So you've got three access modifiers. You've got private, protected, and public. And they're just ways of indicating to the rest of the world which of your code is kind of yours. You don't expect people to use it. Perhaps you've got implementation details in a function that you don't really want people to rely on. You don't want people to call that function, so you mark it as private. And that means that they won't be able, they can use your class, but they won't be able to call that function. And then later on, you can change how that function works without worry that somebody has accidentally started using your function because you marked it as private. So this is what we call the access modification. And if we use access modifiers, there's a really neat shortcut in TypeScript that we can use. So if we perhaps type private first name, private last name in the constructor parameter list, it automatically assumes that we want to create a member variable, call that, so we don't need to define this anymore. So just define those for us. And it also assumes that we just want to assign whatever value we pass in to that member variable. So we can actually just skip both of those out. Pretty neat feature of TypeScript, in my opinion, and then everything works just as it worked before. So in summary, in ES6, we now have a new way of writing object-oriented code with this class syntax. But under the hood, we're still using the old prototype-based inheritance, but the syntax is easier to understand and more familiar for developers who are coming from other languages. And TypeScript adds some extra functionality on top of ES6 classes with access modifiers. Hey guys, okay, still looking good. I might not make it all of the way through the content. I was hoping to make it through a lot more. I think I'll probably stop off. I'm going to skip to modules. Okay, let's do modules. Okay, so another feature we have in ES6 is we have a module-based syntax, a module loader, okay? So by default, JavaScript doesn't have a module system like in other languages such as Java or Python. That means that if you wanted to load some functionality, you have to explicitly load all the JavaScript files that contain that functionality that you need. And if you're in the browser, like via script tags, you have to load up all that code in your browser and then use whatever function that code loaded up via the script tag. But in other languages, they have a module system. So in Python, if you wanted to use some code from another file, you would type something like this. Let me create a file, actually. Call it module1.ts. I'm just writing sudo Python here. So in Python, we might have import foo from var. Okay. So and then we might call foo. So in Python then figures out like what bar is, what code that is, actually loads up the file from the disk, actually loads the code from that file, finds the function foo in that code and makes it available to our module so we can call it. Okay, pretty cool, right? So this was missing, this kind of functionality was missing in JavaScript. So the community developed a couple of different solutions. We've got CommonJS, which is used in Node. And we've got something called the AMD asynchronous module definition. And these are still in kind of really wide use today. And they provide features provide complex features such as handling circular dependencies. And confusingly, in Angular 1, they introduced their own module system that's differed from the two above. In ES6, they took the best of the existing module systems and introduced this concept on a language level. But it's not actually implemented natively yet. We still need to use a polyfill. So we'll write this using TypeScript, which will compile down to using the CommonJS system. So let me just copy and paste some code on screen because we're running out of time. I've got in my module1 file, I've created a function called square, which just squares a number, a function called cow, which just logs moo, and then I've got this new syntax at the bottom, which is export. And it looks like a destructuring syntax here, and it is. So we're exporting square and cow. So we're saying that the square and cow functions from this module are exportable, which means they're importable somewhere else. So let's now import them somewhere else, let me create another module called module 2. Yes. So in this module, I'm going to type import square from, and then I type the name of the module where I'm importing it, the file where I'm importing it from, which is module 1. And then I can just call square just like I would call it anywhere else. So now, make sure I'm this one, because ES6 doesn't quite support module systems yet, we have to use ES5, which means it will use common JS. So if I now type module 1.ts and module 2.ts, it's going to compile both. There we go. And just to load it up, you can see it's actually, well, it's using the common JS mechanism of exporting and importing modules. So you've got exports, and in the consuming, we're using require. So this is just how it's kind of polyfilling and implementing this kind of module loading for us. But we can still use the new syntax. But underneath, it'll just use an old mechanism until the engines really figure out how they want to do module loading and build it natively into the platforms. Okay, so now we just want to run it. So node module 2.js. Oh, I need to log it. And there we go. It's printing out 16, which is a square of 4. And we can also, if I want to call cow, which you remember was in the module 1 as well, I can just import cow just like that, pull it, and it's going to print out moo as well. Okay, so another thing we might want to do is we might want to import some a function, but just call it a different name. So we can do import square as squa, and then just call squa locally in our code, and that'll work just as well. Or we can import everything into a named variable. So import start as utils, and then I can call utils.square, square, and utils.cow. And then, yep, that works just as before. And also, we have an alternative exporting syntax. So I showed you how to export using just one keyword at the end of the file. But what we can also do is, before we type the function, we can type export. So export function square and export function cow. That's just the same, just as equivalent as before. So now if I run the file, you can see it will still import those functions in module 2. And the final thing I'm going to show you is that if you have one function in your module, which is just, well, you expect that to be used far more than anything else, you can declare it as default. So let's say in my file, I expect the square function to be used far more than anything else. Then if you do that, then in your importing, you don't have to use this destructuring syntax, these curly braces. You can just do import square and then just call it again. But at the same time, if you still did want to import square and cow, you could then still have this kind of syntax where you then do comma and then open it, and then the braces, and then cow. There we go, back to square one again. So now we've got modules that we can import and export. And I've showed you how we can define the two different ways of defining the exports within a function. You can have the explicit export keyword at the end, or you can prepend it to functions, and you can also define default exports. And I've showed you how to import functions from other modules, how to use aliases, and how to import default values as well. Okay, that's modules, guys. Yeah, this editor is called, this is PyCharm. It's the same as WebStorm from JetBrains. Okay, got a request to do decorators. That's the bit that I don't really understand. Well, fine, let's do decorators. I'm always going to skip it out, but I think I've got time to do it. Yeah, let's do decorators. It's actually quite simple. Okay, decorators. .ts. Now, you saw me kind of use, if you watched the quick start with me, you saw me use decorators. So if you remember, I had some code that was like something like a decorator, an annotation that starts with @ and then the name of something. And well, I don't know, you probably thought that was a bit of magic. It's actually really, really simple. Okay. Now, decorators are kind of still in discussion in the JavaScript standard. They're not in ES6 yet. They're not implemented yet. But we can actually write them using TypeScript. Okay, and TypeScript will compile them into something that works for us. Okay, so okay, so the specific implementation, how Angular implements it, might be a lot more difficult and harder to understand. A simple decorator is actually really, really simple to understand. Now, let me just grab some code from the class. So let me grab that person code and put that in the decorator class here. Okay. Let's imagine I'm going to create a decorator for the person class called course. Okay. All that course is, okay, so I've just done @ and course. All that course is a function called course. That's it. Decorators are not hard, people. They're actually really simple. So it's just a function called course. Okay, now the first parameter to the function is the thing that you're decorating. So we're decorating a class, but you could decorate a member variable, a function, whatever. The thing that you're decorating is the first parameter that gets passed in. So I can show you that by doing console.log target. Okay. So now if let me make sure I'm compiling this. Let's do, we can do ES5. Decorators. Okay. So now if I do node decorators, you can see that what gets printed out is function person. That's because the reason it's function person, not class person, is that, as I said before, classes are implemented using the old mechanism, and it's implemented using function constructor functions. So underneath all of this class stuff, it's just a function. So that's why it says function person. Okay, but it's still just a class. It's still just a class. But what we can do is we can actually kind of add things to our class, add code to our class. I'm just copying and pasting this code in. So we can use a feature of object called define property. I won't go into this so the details of this implementation is beyond this lecture, right? But essentially, this adds a function called course to the target, and the function itself, I've used the fat arrow syntax, is just a function. It just returns the string, well, let's call it TypeScript. Just returns the string TypeScript. So this adds a function called course. This is the function that it adds, and all this function is doing is returning the string TypeScript. So now, if I did let asim equals new person asim same, I can do console.log asim.course function, so I have to call it. Now you can see it prints out TypeScript. So we've just decorated our person class, added a function to it, okay, a function called course, and we're printing it out. So hopefully now you start getting an idea of what a decorator is in TypeScript, and especially in hopefully this is going to clear up some of the stuff you're seeing in Angular 2, because it's not magic, people. It's really simple. But what you see in Angular 2 is you see something a bit like this. So you have decorator like that. You pass in a bit of configuration, and maybe you'd do something like that. Okay, so you'd be able to configure your decorator with an object that gets passed in. Now you can do that again. It's really simple. It's just, again, we create a function called student that takes a config. Okay, that's all that is. That's a function called student, takes the config, this config here. And all the student has to return is a function. So we just need to return this function. Okay, it can be an anonymous function now. It doesn't need to have a name. And instead of hard coding TypeScript, remember we're passing in this config object is this thing here, and we're passing in course. So we can just say config type course. Okay. So the student decorator is a function that takes an object and returns a function, and that function it returns is the thing that actually decorates this person class. Okay, and then we can pass in configuration and basically have configurable decorators. And now if I run this, I'll print out TypeScript again, because we've done the same thing. I've just added a function called course and just made it configurable. So now we can actually type in configure our class using a bunch of different parameters to our student decorator. Okay, so decorators, they're a new feature. They're used throughout Angular 2 code, but they are nothing to be scared of. They're just functions that can be used to add metadata, properties, and functions to the thing that they are attached to. Okay, hopefully, that answers your question. Oh, guys, is nothing working? Guys, has any of this worked all the way through? Have you seen? Is it just been my head talking this entire time? Please tell me no. Oh, you're kidding me. Are you seeing this now? So, oh my God. I really do apologize, guys. It sounds like... Can you see now? Okay, just really quickly. Has it been my face this entire time? Or have you seen any of my screen? Okay, just decorators. So just for decorators, it went a bit messed up. Do you know what I might do? Oh, okay. Okay. What I might do is I might just re-record this whole thing and send it out to you guys again. But do you want me to go through decorators? Okay, I'll go through decorators, but I think I'll probably, annoyingly, I'll have to stop it there because it's overrunning a bit too much. But yeah, I'll go through decorators again. So super sorry about that, guys. Super sorry about that, guys. I'm not too sure what happened. Okay, hopefully everything's fine. Annoying. Okay, let me do it one more time. So let me... Sorry, 1 second. Okay, cool. Yeah, just getting messages from people. Okay, let me do it one more time then. Okay, I'm going to double check. You can see this. Okay, let me do this one more time, because decorators is actually a pretty cool feature, and I think it's very easy, to be honest with you. But let me do it one more time. Okay, so I've got a person class here. I want to add a decorator to the person class called course. Okay, let me quickly go back to where I was. Okay, so we add a decorator with just this @ symbol, @course. Okay, so all that a decorator is just a function, guys. That's all it is. No magic. The only thing is the first parameter that gets passed the function is the thing that's getting decorated. So the class here is getting decorated, so it gets passed as the first parameter to the course function. Console log target, and then if I now just create an instance of this class, all node decorators, you can see function person gets printed out. Why is it function person and not class person? That's because underneath this class syntax, we're still using function constructors, just how to in implementing JavaScript, and yeah, that's why it's saying function person. But all that this decorator is a function. That's it. Now, to do something interesting with this function, we can do something like this. Yeah? Object, we can use object.define property. And I won't go through what this specifically means, because to understand this, you have to understand the prototype chain. But essentially, this is adding a function called course to the target. And the function is this function here, this fat arrow function. So it's just adding a function called course, and all that function does is return the string Angular 1. Actually, let's make it type script. Let's make it return TypeScript. Okay. And then all we do is we could do console log asim.course, and then sugar, and then node decorators, and boom, we're now printing out TypeScript. Yeah. So that's all that a decorator is. It's just a function that gets past the thing it's decorating, and then you have to do some magic to kind of make that thing adjust in whatever way you want it to adjust. And you can add properties, add checks, do a bunch of different things. All we've done is add a function called course that returns the string TypeScript. But in Angular 2, in the Angular 2 quick start, you probably noticed, something like this, which is a you probably saw things like components and decorators, which could take in objects and multiple parameters like that. And again, that's really, really simple, because just like before, student is just a function. Okay, function that takes in an object, a function that returns the function that you want to decorate the target with. Okay, we don't need to name this function anymore. Okay, so that's all that student is it takes in this object here, that's config, and returns a decorator, which is used to decorate the thing that it's attached to. Okay, it's the same as before, we're just adding the course, but instead of the value, instead of hard coding that to TypeScript, we can now use the configuration that was passed into the student function and config.course, just like that. And that's it. So that's how we can, and then if I run that, sorry, let me run it, make sure it works. There you go. That's how we can configure, create configurable decorators, which just decorate classes. So let's imagine a world where we're all looking at Angular 3, and then it prints out Angular 3. So that's it, people. That's all. That's what decorators are. They're a new feature. They're not quite in ES6 yet. They're going to be in ES7, I believe. And they're used throughout the Angular 2 code. They're kind of polyfilled in TypeScript. That's why we can use them. But they're nothing to be scared of. They're just functions, and they can be used to add metadata, properties, and functions to the thing that they are attached to. Hopefully, everybody got that? Yes. Excellent. Okay. Now, do I have time for the last thing? Yes, I might as well cover the last thing. Okay. So the last thing with TypeScript is, as you can imagine, types. Make sure I'm sharing. Okay, types. It's in the hint is in the name, people. It's TypeScript, so it's all about types. So some of the most common mistakes we make while writing JavaScript code is to misspell a property or a method name or something like that. And we'll usually find out about that mistakes when we get a runtime error. So when we're actually running our application, which is why testing in JavaScript is so important, because it's kind of the only way to test for correctness of our application. But other languages like C++ or Java have something called kind of static checking. So during the compilation phase, it first checks to see for some simple mistakes and raises an error. So TypeScript also provides a compiler. It's what we call the transpiler. Okay, so when it actually transpiles from TypeScript to like ES5 or ES6, it checks for some of these mistakes using some static analysis. It only really works when we tell TypeScript the type of things. So things such as variables we declare or parameters we define in functions. So for example, in JavaScript, we might type let a, and then a is equal to 1, and a is equal to 2. So somewhere by accident, we wrote this, we made it assign the string 2 instead of the number 2. Now, we always intended for it to have the number, to always hold numbers, but by accident, we made it hold a string. Okay, in normal JavaScript, this is not an error. This is not a problem at all. Okay, but it's probably going to cause us a headache somewhere down the line. But with TypeScript specifically, we can tell it that we expect a to be a number. And you can see my editor immediately it said, give me an error when I tried to assign a to a string, because it's a string is not a number. Let me actually get this. So let me do types.ts. Okay. So it specifically gives us an error here. So type string is not assignable to type number. Okay. So there's a bunch of different types that we can have in TypeScript. So we can have number, we can have string, we can have Boolean, so it's true or false. We can have function, so we can say a will hold a function. Oh. Or we can have array type, so number and an array of numbers. Okay, so we can hold, a will then only hold an array of numbers. Okay, and if we try to make it hold something else, it will give us an error. We can have something called an enum type. So enum, let me copy and paste it. Enum direction. So direction is a type which you can only have 4 values, up, down, left, or right. And then we can let a be of type direction, and a equal to direction or up. Okay, and that's fine. Try to make it equal to something else, it's a problem. Okay. Okay, so another thing you should know is that kind of types are, well, basically optional, right? You don't, in TypeScript, you don't actually have to give a type. Okay, you can just leave it out and it'll just behave as if it was a type of any. So any can mean, well, anything really. But I would say to use TypeScript, don't use types as much as possible, and very, very rarely use any, because it's usually a bad indication that something's not quite right with your code. Okay. And it also can do something pretty cool. So it can actually infer your type for you. So if I let a equals 1, as long as I declare it all on one line, it then knows that it then infers that A will only ever hold numbers from this point forward. So if we then did A is equal to 2, it's going to be an error because it's inferred from this line here that A is of type number. Okay, that's called type inference in TypeScript. Okay, and there's also a way with TypeScript of so as long as everything you've written is written using TypeScript, and then it compiles with a TypeScript compiler, it will give you these errors. It will give you these errors, and then hopefully, fingers crossed, those errors will tell you problems early with your code, so you're not chasing your tail, trying to figure out a runtime problem sometime later on. Okay, guys, I think I'm going to have to leave it there. And yeah, we've kind of covered all the topics. Well, it rushed through the last one, I suppose, but we've covered all the topics I wanted to cover. I again apologize for having to go through decorators again. I don't know what happened there. If anybody's got any questions, I've got a few minutes worth of questions, but unfortunately, I have to head off personally. Let me just check the Q&A column. So Jose asking, what would those numbers in the right bottom corner of your code editor mean? I actually can't see them because they're hidden by the Google Hangouts thing. Oh, it's just the memory and just the memory used by the editor and various other bits and pieces. I've done the decorators. Okay. Yeah, so that's it, guys. Reminder. Can you chain together fat arrow functions? That's actually a very good question. Now, let me look into that, and I'll answer it via email. Abdul is asking, transpiling isn't an extra process like we are first converting it to ES6 and all. Transpiling is an extra process. So we first convert it into ES5 or ES6 or wherever we want to run it. There's no there's no node, or the browser doesn't support TypeScript natively, so we have to convert it into something that supports it. And maybe one day somebody will create, maybe there is something I haven't checked actually, something that actually runs TypeScript natively. But if there is, it's not used in things that are useful to us. We have to convert it to something else. Can we say that TypeScript is both? Edward is asking, can we say that TypeScript is both static and dynamic type language? Yeah, I think it's safe to say that, actually. Or maybe specifically, if you don't specify a type, it assumes a type of any. Maybe that's a clearer way of saying it, is that it is a typed language, but it has this kind of cheat type of any. So if you don't specify any type, it just assumes any. Okay, James has answered it. Answered the chaining question. Yes, you can chain fat arrows. Yeah, yes, you can chain fat arrows. So thanks for that, James. And Techie Twom. Yes, this webinar is going to be available later. I'll post it out via an email to everybody who attended and possibly everybody else as well. And again, guys, I mean, I'm going to plug my stuff, of course. But if you are interested, you can head on over to my Kickstarter. And yeah, I'm kind of more than halfway through now. But yeah, I'd appreciate it if you do. Unfortunately, all the early birds have gone now, but we still have a bunch of the other pledges to go. You can get my Angular course for 15 quid. You get the 1 and 2 bundle. You can get it for 25. So as soon as the whole thing gets funded, I'll send out details how you get the Angular 1 course, and then once 2 is completed, you get 2 as well. But not only just once 2 is completed, as I'm creating 2, you'll get early access to all the content as we're going along. And then you can also get the 1 + 2 + JavaScript bundle. Now, my JavaScript course is actually one of my best courses, my most popular ones. It's one of my highest scoring ones anyway. And I really do recommend having a good knowledge of JavaScript in just anything, really. I think the reason I created it is because, well, a lot of the courses I do involve JavaScript, and yet the standard of a lot of my students kind of varied of the JavaScript. So I would definitely recommend just getting the advanced JavaScript course if you're interested. But again, if you go for the bundle, you can get the 1 + 2 + JavaScript bundle for 35, and for 50, you get everything that I've got. Everything that I've got completely. And I've changed it to £100. But if you are in London and you're interested in classroom training, you can get, I'm trialing this out to do classroom training. Teaching online is really enjoyable. It's really nice, but I do miss having one-to-one interaction with students. So I'm trying this out to see if anybody's interested in classroom training in London. It's a really cheap price. £100 will just about be cost at the end of the day for a room with maybe some lunch. And it'll be a 2-day weekend course where we'll go through the same content as the Angular 2 course. I'll just be a chance for you just to interact with me directly and just really very, very quickly get a dump of Angular 2 into your brains. So yeah, it's going to be held somewhere in London in October 2016. The venue's TBD, but it'll be in zone 1 or 2. Go ahead and back it if you want. If you back it and there's only like 1 or 2 people who go for it, I'll refund the difference, or we can work something else out. But yeah, that's the last pledge that I've got there. And unfortunately, guys, I have to actually leave now. I've got a gym session booked that I cannot be late for. But where are you? But yeah, thanks a lot for everything, guys. I'm going to send everything out via an email afterwards, probably a couple of hours later. And then, yeah, cheers. Thanks a lot. Oh, Techie Twom, send me an email to codecraft.com. Yeah, I'm interested. Just give me a shout. Jose, the lessons won't be during the week. I imagine they're probably going to be on the weekend, just to make it more convenient for everybody else. But yeah, I have to go, guys. If you've got any other questions, just drop me a mail to ask@codecraftpro.com, or message me on Twitter at @Joeake. All right, guys. Thanks a lot. See you later. Bye.